this is just still solving basic trig equations. You guys will be given your identity sheets on your test, which is going to be on Friday. We're just going to practice the next few days after we do these examples in preparation for that test. But if you look at this first equation, told you guys yesterday, we're going to kind of have like a step-by-step process of what we do. The first thing I told you to do was rewrite the equation. So let's rewrite this as 1 plus sine theta equals 2 times cosine squared theta. All right, just rewrite the problem. Now, this is different from yesterday because everything yesterday was all set equal to 0. We can do that same thing here. We can get this equation set equal to 0. We would just move this 2 cosine squared theta to the other side. So that would give me 1 plus the sine of theta minus 2 cosine squared theta, and that equals 0. The reason it's minus is because you moved it from one side where it's positive to the other side to make it negative. Now, if I highlight, like I told you guys to do yesterday, if I highlight my trig functions, what do you notice about them? They're what? Are they the same or different? They're different, all right? So we have a way to turn cosine squared into sine. Do you guys remember this theorem, or this Pythagorean identity? Sine squared theta plus cosine squared theta equals 1. You guys remember that? From our verifying and stuff? You're going to get your trig identities. Now, if I wanted to change cosine squared into something in terms of sine, how would I do that? How would I get this how would I get this cosine all by itself? What would I have to do? What would I have to do with the sine squared? How would I get cosine squared theta all by itself? Not yet. Just subtract it. So I would subtract sine squared theta on this side, and then I subtract sine squared theta on this side. Now, do I now have cosine squared in terms of sine? Yes or no? Yes, so I can rewrite this as 1 plus sine theta minus 2. Instead of cosine, I'm going to replace it with 1 minus sine squared. And then I have equals 0. And now this is just a basic algebra problem. What do I do with that 2 that's out in front? I have to distribute it. Good. So I have 1 plus sine theta minus 2 plus 2 sine squared theta equals 0. Now clean it up. Do you have any like terms? One and negative 2? All right, so I can write 2 sine squared theta plus the sine of theta, and then what's a 1 and a negative 2? Minus 1 equals 0. Now, does this look like a factoring problem that we did yesterday? Yes, right? I can rewrite this if I wanted to. I could rewrite this in terms of x, so it looks a little more familiar to what we've done before. All I did was just replace my sine, my trig function sine, with x. And how would I factor this? 2 times negative 1 gives me negative 2. So what are the factors of negative 2 that multiply to give me a negative 2 but add to give me a positive 1? Positive 2, negative 1, good. And then since my a term, God bless you, is not 1, I have to divide 2 underneath here. So this leaves me with x plus 1 times 2x minus 1 equals 0. You guys with me? Now we take that step, excuse me, because we are talking about a trig equation, and I'm going to replace my x's with sines. So this is the same as saying sine theta plus 1 equals 0. And the other one is 2 times the sine of theta minus 1. 2 sine theta minus 1 equals 0. And then we solve. Over here, we're going to minus 1 from both sides. You guys agree? So you have the sine of theta equals negative 1. What am I going to do over here? Add 1 and and divide by 2. Good. So you get the sine of theta equals 1/2. Now that's all the algebra stuff. That's done. Now we can go back to say, okay, let's solve our trig equation. What does sine mean? What values? Our y values? So I'm looking on my unit circle for where my y values are -1 and +1/2. So let's do -1 first. Where on my unit circle is the y value -1? 3 pi over 2. Good. So one of my answers is 3 pi over 2. Now I look to see where on the unit circle my y values are 1/2, which are where? +1/2. Pi over 6 and 5 pi over 6. Good. So pi over 6 and 5 pi over 6. Good. Good. Questions? Skip the next one. So now come to, we're talking about functions of multiple angles. All right, this gives us one extra step. We're either going to have to multiply at the end or divide. That's it. Same exact concept. We do the same things the same way. We just have to multiply or divide at the end. Don't worry about this. All we're going to do is solve. What's the first thing I told you to do when you get a trig equation? Rewrite it. So I have 2 times the sine of 3 theta minus 1 equals 0. How is this, when I highlight my trig function, how is this different from what we've been doing? Why does this one look a little different? Nobody sees anything any different? It's sine, that's fine, but what do you notice right here? There's a 3 in between the trig function and the theta. When you have a number there, that means, oops, I have one more extra step. If I wanted to get that trig function by itself, what would we do? What would I do with the -1 and the 2? Add 1, right? 2 times the sine of 3 theta equals 1, and then divide by 2. Same exact steps, same rules, same everything. I cannot take away that 3. I can't do anything with it because it's stuck inside that trig function. So again, guys, where on the unit circle sine is y value, so where on the unit circle are your y values 1/2? Go over and look. Where are my y values 1/2? Pi over 6 and 5 pi over 6. I agree. Pi over 6 and 5 pi over 6. Now here is the extra little step. Before, guys, when we found sine of theta, we were just finding theta equals. But this isn't theta, this is what? 3 theta. This is saying that 3 theta equals pi over 6, and 3 theta equals 5 pi over 6. Well, how do you get theta all by itself? Divide by 3. If I divide by 3 on this side, I'm going to divide by 3 on this side. I'm going to put 3 over 1, and you'll see why in a second. It's just easier to see. When we work this out, we keep, change, flip, right? So it's pi over 6 times, when I flip 3 over 1, what does it become? 1 over 3. So my answer here is pi over 18. If you don't put that 1 underneath, some of you will go keep, pi over 6, change to multiply, and then you'll say times 3. And it's not 3, it's times 1/3. So same thing here on the bottom. We're going to divide both sides by 3. Keep 5 pi over 6. Change division and multiplication. And I flip. This is really 3 over 1, so that becomes 1 over 3. So I end up with 5 pi over what? 18. Perfect. Good. So when you have a number either multiplied by theta or you're dividing theta by the number, you're going to have one extra step. This is called the function of multiple angles. So if I look at this next example, all right, again, don't worry about this. We're not talking about specific intervals or anything. We're just talking about solving. What's the first thing I should do here? Rewrite it. So I have the square root of 3 times the tangent of theta divided by 2 minus 1 equals 0. All right, go through our normal steps. Go through our normal steps. We're going to highlight our trig function. That theta divided by 2 is stuck with it. Can't do anything with it. So what am I going to do? How do I get tangent of theta divided by 2 by itself? Add 1 and? That says root 3 times tangent. I would add 1 to both sides. So I'm left with the square root of 3 times the tangent of theta over 2 equals 1. Guys, if that was a whole number 2, what would you do to both sides? Divide. So that's all we're doing is just dividing. We're going to divide this side by the square root of 3 and this side by the square root of 3. So I have tangent of theta over 2. Would we ever leave 1 over square root of 3? No. So we would rationalize, right? This becomes root 3 over 3. So it really is like this. Tangent is y over x. Remember, this is where this is really helpful if we could remember where on the unit circle, when I put the y over the x, I get root 3 over 3. Does anybody remember? It's one of these ordered pairs, this one or this one. Does anybody remember which one it is? If you don't remember, then you got to work it out. So put the y over the x. I'll wait for you guys to do it. It is pi over 6. So when your ordered pair has root 3 over 2, comma 1/2, that will result in tangent of root 3 over 3. I want positive root 3 over 3, so it's pi over 6. And then where else on the unit circle will give me positive root 3 over 3? Two is your x coordinate and 1/2 is your y coordinate. Does everyone see that? That means when x is root 3 over 2 and y is 1/2, you'll get a tangent of root 3 over 3. So where else on the unit circle am I going to get a positive root 3 over 3 as my tangent? Out of those other 3 possibilities, which one's going to give me a positive? Why is it 7 pi over 6? Because they're both negative. Good. So 7 pi over 6. Now, if it said tangent equals, we would be good to go. But it doesn't say tangent equals. It doesn't say theta equals. What does it say? This doesn't say theta equals. What does it say? Theta over 2. So I have to say theta over 2 equals and theta over 2 equals. How would I get theta all by itself? Multiply by 2. What's the opposite of division? Multiplication. So you multiply one side, you do to the other. 2 goes into 2 once, 2 goes into 6 3 times, so I get pi over 3. Multiply 2 on the top here. I multiply 2. So 2 goes into 2 once. 2 goes into 6 3 times. I get 7 pi over 3. All right, it's one extra step. When you have a number either being multiplied or when theta is divided by a number, it's one extra step. Super important for you guys to remember.